Hello and welcome to Retrieval-Augmented Generation course, your complete guide to mastering one of the most powerful technologies in modern AI. In this course, we'll start with the basic of RAG, helping you understand how it blends information retrieval with language generation to deliver more accurate and grounded AI responses. We will then explore how RAG compares with CAG, which is Cache-Augmented Generation, breaking down the differences, use case, and strengths of each approach. From there, we'll dive into the role of web crawlers in RAG systems, showing you how data is gathered, structured, and made usable through tools like Crawl for AI. Whether you're a beginner or an AI practitioner looking to build smarter and context aware systems, this course is designed to give you the clarity, tools, and confidence to work with retrieval augmented generation in real world. Let's get started. If you're interested in mastering the future technology, the professional certificate course in generative AI and machine learning is a perfect opportunity for you. Offered in collaboration with ENICT Academy, IIT Kanpur, this 11-month live and interactive program provides hands-on expertise in cutting-edge areas like generative AI, machine learning, and tools such as ChatGPT, DALL-E 2, and Hugging Face. You'll gain practical experience through 15 plus project, integrated labs, and live masterclasses delivered by esteemed IIT Kanpur faculty. Alongside earning a prestigious certificate from IIT Kanpur, you'll receive official Microsoft badges for Azure AI courses and career support through Simplilearn's Job Assistant program. Hurry up and enroll now. Find the course in the description box and in the pinned comments.
Have you ever wondered, guys, that how AI models like ChatGPT or Google Bard generate answers? Well, they are impressive tools, but they have just one big limitation. They are only as good as the data they have been trained on. That means they don't always have the most up-to-date information or access to specific knowledge beyond their training period. But what if there is a way for these models to go beyond their training and pull in real-time external data to improve their answers? That's right, guys, and the answer is with the help of RAG. So guys, in today's video, we are going to learn about Retrieval-Augmented Generation. So guys, imagine a scenario where a child asks their mother, which planet has the most moons? Based on what she learned in her school, the mother confidently responds that Jupiter has the most moons. Her answer is correct according to the knowledge she has gained some times ago. But what she doesn't know is that more recent discoveries have changed this fact. This is where two main issues come with traditional large language models. The first one is no external data source. So with respect to this case, the mother is solely relying on the information stored in her memory without consulting any external sources like a book or the internet. This is exactly what happens with LLMs like ChatGPT. They can generate answers based on the data they were trained on, and they don't have access to real-time updates unless specifically programmed to do so. Next one is outdated information. Since the mother hasn't kept up with the latest astronomical discoveries, her knowledge is outdated. This is another common problem with LLMs. They are trained on a fixed data set up to a certain point, which means they don't have access to new information after all. Now, imagine if the mother had access to the real-time databases like encyclopedia or an internet-connected device. She could quickly look up at the latest data and the number of moons each planet has. So guys, that's where Retrieval-Augmented Generation comes into the play. If mother had access to search engine or a database, RAG can retrieve information from external sources, whether it's databases, websites, or other documents, allowing them to answer queries based on both internal knowledge and external data. So instead of simply relying on what it knows, the AI retrieves new information when asked something that falls outside its knowledge base. When it involves recent events or facts, this ensures that the model can stay relevant and accurate. If we talk about what exactly is RAG, so guys, RAG is a framework that enhances the capabilities of a large language model by incorporating external knowledge through retrieval mechanism. So guys, this basically system is designed to improve accuracy, relevance, especially when you're dealing with the complex questions. Now let us try to understand the components of RAG. So guys, the first one is retrieval, second one is generation, third one is augmentation. So guys, our first step is retrieval. The retrieval process in the mother case would be that she has to access a search engine or a database so that she could retrieve the most up-to-date information on the number of moons. This is what RAG models do. They can retrieve information from external sources, whether it's databases, websites, or other documents, allowing them to answer queries based on both internal knowledge and external data. So instead of simply relying on what it knows, the AI retrieves the new information when asked something that falls outside the knowledge base or when it involves recent event or facts. This ensures that the model can stay relevant and accurate. Next one we have augmentation. Once the mother retrieves this data, in this case, she augments her knowledge with the new information. She combines what she just learned with her previous understanding of the solar system. This augmentation process happens in RAG, where the model takes the retrieved information and merges it with pre existing knowledge to give a more complete and accurate response. This is critical because it ensures that the answer is just not direct quote from the retrieved data, but an enhanced and well rounded response that incorporates both past knowledge and newly retrieved facts. Now, let us talk about generation, guys. Now, the mother is ready to provide the final answer to her child. She generates the response, actually, like Saturn now has the most moons. So, say the number is 83. So, here, the final step is the generation phase, where the AI produces an answer that is both up to date and comprehensive. So, by combining retrieval and augmentation, AI can generate a response that is far more accurate and simply relying on its base training. This is why RAG is so powerful, guys, because it actually bridges the gap between outdated knowledge and the real time data, making LLMs more reliable and relevant. Now, let us move ahead and let us discuss about the components of RAG in a diagram. So, as you can see, suppose a user asks a question. So, here is a smart retriever. Then it looks for a specific knowledge. So, there is a knowledge base and it gives the relevant documents. So, guys, let us take an example. Suppose you type a question. So, there will be a smart receiver. So smart receiver is going to look for a specific knowledge base and it is going to give the relevant documents. Now, the question plus the relevant documents are going to be sent to the LLM as a generator, and then it's going to generate an explicit source informed content. So you can see like how RAG is working in this scenario. Now let us take some key applications where RAG is playing a major role. The first one that we have all over here is customer support and chatbots. So RAG can power customer service bots that can provide accurate, up-to-date responses to customer queries. Instead of being limited to the pre-trained data, the model can retrieve the latest information from a company's internal knowledge base or a website, making it more effective in handling queries about new products, services, or policies. Then next we have is search engines. RAG can be integrated into search engines to enhance the relevance and accuracy of the results. Instead of just returning a list of documents, the model can retrieve relevant documents, augment the search results, and generate more refined answers to complex queries. This improves the search experience for users by providing both data and explanations in one place. Next, we have research and development. In R&D environments, RAG can assist researchers in accessing the latest scientific publications, patents, and reports. It can generate summaries or new insights based on retrieved data from databases or academic journals, helping scientists stay updated on the new findings without manually going through the large volume of research. Next we have is content creation. So guys, for content writers and marketers, RAG can retrieve information on the latest trends, data points, and research, and then help in generating high-quality, accurate content. It can assist in writing blog posts, articles, or reports by gathering relevant data from multiple sources and synthesizing it into a coherent narrative. Next one, we have AI-powered assistants. Personal digital assistants like Siri or Alexa can also use RAG to improve the quality and relevance of the responses they provide. Next, we have is personalized learning. So RAG can also play a very major role in personalized learning. Suppose an edtech app is using RAG to make a more personalized application for the learner. And finally, we see e-commerce. So guys, in e-commerce, RAG can enhance product recommendation systems by retrieving updated information on product reviews, customer preferences, or industry trends. It can help generate product descriptions or suggest personalized products to customers based on real-time data from the market. In all of these applications, RAG provides a powerful mechanism for combining retrieval of real-time external information with generation of insightful, up-to-date responses, making it an essential tool for industries that require both accuracy and current information.
Welcome to the Retrieval-Augmented Generation for Beginners course by Simplilearn. So in this course, we will understand initially the introduction to RAG, and then we will get into the components of RAG, and after that, we will dive deep into the data loading as well as text splitting, and then we will see storing the chunks in vector stores and embeddings, and then we will see how to retrieve the data. The most importantly, we will build a multi-document agent, and finally, we will conclude the course. So let us begin with the first chapter, that is Introduction to Retrieval-Augmented Generation. So let us begin with the first chapter, that is the Introduction to Retrieval-Augmented Generation. So imagine you are chatting with an AI and you ask it a question. Who won the FIFA World Cup in 2022? The AI can't just guess. It needs real information. But most language models like the ChatGPT are only trained up to a certain point in time. So if something happened after their training, they wouldn't know about it. Then their RAG comes. The short for Retrieval Augmented Generation solves this problem. So let us now understand what is RAG. RAG is like giving your AI a powerful search engine buddy. So instead of depending only on what it remembers from its training, it also retrieves the latest and the most relevant information from a connected source, like a document, knowledge base, or even the web, and then uses the information to generate a better response. So, RAG is equal to retrieval, that is find information, plus generation, that is writing answers. Think of it as a student taking an open book test. First, they look up the question and then they explain it in their own words. So, the question arises, why does it even matter? So, here's the thing. Most traditional language models have a knowledge cutoff. That means they don't know anything that happened after a specific date. So, RAG helps fix these problems. It improves accuracy by pooling the real information when needed. Then it provides the up-to-date responses, even if the AI was trained years ago. Then it reduces hallucination because it uses facts instead of making educated guesses. Then it makes AI more trustworthy in the critical tasks like the legal, healthcare, or even enterprise search. Now let us move and see what are its use cases. So RAG is super useful in many real-world situations, especially when accuracy and up-to-date knowledge are important. So here are a few examples. The first example we have is customer support bots. They can pull answers from the help docs, facts, or internal knowledge bases to give the relevant and the accurate responses. Then we have enterprise search. So employees can ask questions and get answers from the company documents, manuals, or the HR policies. Then we have healthcare. Doctors can ask about treatment guidelines and RAG pulls information from the recent medical research papers. Then we have legal. The law firms can use RAG to find and summarize the case laws from a massive legal document repository. Then we have education, and students can ask questions and then AI finds the best answer from the textbooks or notes. So now let's move on and see how does RAG work. So let's break it down into the simple steps. The first step is the user asks a question. Then you type something like, what are the side effects of aspirin? And then step 2 is retrieve. So instead of only relying on its memory, the AI first searches a connected database like medical documents, articles, or PDFs. So this is done using something called a retriever model like the BM25 or dense vector search. Then we have the third step as augment. The most relevant documents or snippets are selected and combined with your question. And then we have our fourth step, that is generate. Now the language model like the GPT or the BERT takes this context and generates a final answer based on the real information it just retrieved. It's like asking a librarian a question and that is compared with AI. The librarian doesn't just answer from the memory. They first find the right book, that is the retriever here, and then read the right page, that is the augmentation, and then explain the answer to you in simple language, and that is generation. Then let's move on to the next chapter and see the core components of RAG pipeline. In this chapter, we will understand about the core components of the RAG pipeline. So to understand how retrieval-augmented generation works, we first need to meet its core building blocks. The RAG pipeline is not a single model. It's a smart system made up of multiple documents, each playing a unique role. So here's a quick overview of the 6 major components. So what are the components of the RAG pipeline? The first component we have is query encoder. Then we have retriever. The third one is the knowledge base, also known as the document store. Then we have the re-ranker. The fifth one is the generator, that is a language model. And then finally we have the last one as feedback logo. Now let's break down each one to see what it does and how it helps the RAG system. The first we have query encoder. So what it does? The query encoder takes the user's question like what are the benefits of green tea, and it turns into a mathematical formula called a vector. So this makes the question searchable by the machines. Now, how it helps RAG? So without encoding, the system can't compare your question to the information in the knowledge base. The encoder makes sure that your query is in a format the retriever can understand and match with the relevant content. Then let's move on to the second one. We have retriever. So what it does? The retriever uses the encoded query to search through the knowledge base and fetch the top matching documents or passages. So how it helps the RAG? This is where the RAG starts becoming powerful. So instead of relying on the model's memory, it now brings in fresh, real-world data from the trusted sources. Now, this also boosts the accuracy and reduces hallucinations. Then let's move on to the third one. We have knowledge base, that is a document store. So the knowledge base is the library that holds all your searchable content, like the PDFs, support documents, manuals, research papers, and etc. So how it helps RAG? This is where the truth lives. A well-structured, regularly updated knowledge base ensures your AI assistant can retrieve the current and reliable information. Then let's move on to the fourth one. We have re-rank. So after the retriever pulls the top end documents, the re-ranker re-evaluates and reorders them based on the relevance to the question. Then how it helps RAG? So sometimes the retriever brings okay results, but not in the best order. So the re-ranker acts as a quality checker, pushing the most useful documents to the top before the generator even sees them. Now let's move on to the next one. We have generator, that is the language model. So this is your AI's voice. The generator, like the GPT, takes a question plus top documents and crafts a human-like informative answer. So this is where the magic happens. Instead of guessing based on training data, the model now uses retrieved facts to generate the grounded, accurate responses. Now moving on to the sixth one, we have feedback loop. So the feedback loop collects user reactions like the upvotes, downvotes, or clicks and feeds that back into the system. So the feedback loop collects user actions like upvotes, downvotes, or clicks and feeds that back into the system. So how it helps RAG? So this loop helps the RAG system learn over time. So if users consistently like certain responses or sources, the system adjusts to prioritize them next time. It also helps to retain or fine-tune the retriever and re-ranker. Now let's move on to the next and see the results. In this chapter, we will learn about the document loading and splitting. So in order to create an application where you can have a conversation with your data, you first have to load your data into a format where it can be worked with. That's when LangChain document loaders come into play. We have over 80 different types of document loaders, and in this lesson, we will cover a few to get comfortable with the concept in general. So let's jump in. So let's understand what are loaders. So loaders deal with the specifics of accessing and converting data from a variety of different formats and sources into the standardized format. There can be various places where we can load our data from, like the websites, databases, and YouTube, and many more. And these documents become converted into the data types like PDFs, HTML, JSON, Word, PowerPoint, and more. And so the purpose of different data loaders is to take this variety of data sources and load them into a standard document object, which consists of the content and then associated metadata. So there are various types of document loaders in LangChain. It's not possible to cover them all, but here we have a rough. The first one is public unstructured. So, the data that is freely available to everyone but doesn't have a fixed format. For example, the social media post, blogs, articles, and YouTube videos. Then we have public structured. So here, the freely accessible data that is organized in a clear format. For example, the government census data, stock market data, weather reports, and more. Then we have proprietary unstructured data. That is the private data owned by the companies, but it's unorganized. For example, the customer service mails, internal company reports, recorded phone calls. And then we have this proprietary structured, so the private, well-organized data owned by the companies. A bank's customer transaction records, there is a Netflix user watch history, Amazon sales database, and more. So let's now jump into the fun part where we actually see how actually using document loaders work. So regarding the OpenAI API pricing, you can go directly to this openai.com API pricing wala website, and then when you scroll down, you will see and explore the detailed pricing, and you go there and you will basically find all the latest models with the input, the cached input, and the output as well. So in this course, we are using the GPT 3.5 Turbo, and its input is $3 and the training is $8. And if you contact the pricing, you will see it cost $0.5 and the output is $1.50. You can basically take up any API that suits well in your project. So initially, we are going to import some environment variables that we need, like the OpenAPI key. The first type of documents we're going to use would be PDFs. So let's see this. So we have downloaded the relevant document loader from the LangChain, and we're going to use the PyPDF loader. We have loaded a bunch of PDFs into the documents folder in the workspace. And so let's choose one and put it in the folder. So let's load the document just by calling the load method, and we will run this. Now let's take a look on the length of the pages we have downloaded, and we can see that we have 22 different pages in the PDF. So each one is a unique one. So let's look at the first one. So let's run this. So let's see the first content of the page. You can see the instructor is Andrew. Okay, good morning. Welcome to CS2229, the machine learning class. So this is the first page. So now here you will basically get a piece of information, that is the metadata, and we'll run this. And basically we can see there are two parts. The source. So till that .pdf, basically it is the name of the file we have loaded it from. The other is a page field, and it corresponds to the page of the PDF. So the next type of document we are going to look is at the YouTube content. There's a lot of fun content in YouTube. So a lot of people use document loader to ask questions about the content, lectures, or anything like that. So let's see. So here we have imported certain things. The key parts are YouTube audio loader, which loads an audio file from a YouTube video. The other key part is OpenAI Whisper Parser. This will use the OpenAI's Whisper model, a speech-to-text model that converts the YouTube audio to text format that we can work with. So after the output, we can now specify the URL. So let's see that. So we can now specify the URL, specify a directory in which we save the audio files, and then create a generic loader as a combination of this YouTube audio loader combined with the OpenAI Whisper Parser. And then we can load the documents by calling the loader.load corresponding to YouTube. Take a few minutes to load. So after this, we'll see the next. You can now see that it has generated the first output, and after that, we can actually take a look on the page content. And this is the first part of the transcript from the YouTube video. You can see this. So the next set of documents we are going to go with is how to load the URLs from the internet. So there is a bunch of educational content on the internet, and it will be pretty cool to actually just chat with it. So we are going to enable that by importing the web-based loader from the LangChain. And here basically we can choose any URL. And here I have chosen one markdown file from the GitHub page and created a folder. So let's then called the loader class. So we have called the loader class. Then we can even just take a look at the content, and we can see a lot of blank space over here. And when I scroll down, then you can see some content over here, and then again blank, and then again content. And this is pretty interesting. So finally, we will cover how we can load data from the Notion. You have to follow certain steps from the Notion side to duplicate the page into your own Notion space and export them as Markdown or CSV file. Then unzip it and save it as a folder that contains the Markdown file for the Notion page. So then here we have a specific format, and we can use the Notion directory loader to load the data and get documents that we can work with. Now let's take a look at the first page of the content. And you can see this is a living document with everything we have learned working with people while running a startup. And of course, we continue to learn, therefore it's a document that. So it's basically the part. We can clearly see that it is a Markdown handbook, that is a Blendis employee handbook. And I'm aware that a lot of people has worked with Notion and has a Notion's database. So it's a great opportunity to export that data and bring it here and start working with this. And then finally, we see the metadata over here, Blendis employee handbook. So now, after we have loaded the data successfully, we will now get into and see the splitting of the data. So here, we just went over on how to load the documents into a standard format. Now, we are going to talk about how to split them up in a standard format. So, it may sound easy, but there are a lot of subtitles over here. So, document splitting happens after you have loaded your data into the document format. But before it goes into the vector store, and this may appear really simple. You can basically skip the chunks according to the length of each character or something like that. For example, we have a sentence that the Honda Accord boasts an impressive 192 HP engine paired with a seamless 10-speed automatic transmission, delivering a smooth yet powerful ride that will leave a lasting impression. So we can split this document into two chunks. So the chunk 1 would be the Honda boosts, and then the chunk 2 will be the rest part. An impressive 192 HP engine paired with a seamless 10-speed automatic transmission, delivering a smooth yet powerful ride that will leave a lasting impression. And we are trying to answer one question, that is, what are the specifications of Honda? But here is the tricky part. None of the chunk alone can answer the question. So how you split one information, that is very important to get the relevant chunks of information. So, the basis of all text splitters in LangChain involves splitting chunks in some chunk size with some chunk overlap also. So, there are various types of splitters in LangChain. So, the first one we have the character text splitter. So, it basically splits the text based on a specific character. For example, /n with a chunk size and overlap. And then we have Markdown header text splitter. It splits Markdown documents while preserving the headers and structures. And then we have the token text splitter. That is, it splits the text based on the token count, ensuring the compatibility with LLMs like GPT. And then we have the sentence transformers token text splitter. And it uses the sentence transformers to split the text intelligently based on the semantic meaning. And then we have recursive character text splitter, and it splits text hierarchically, first by large units and then by the smaller ones, that is the sentences and the words. Then we have language, that is used for the language-aware text splitting based on the linguistic rules. And then we have NLTK text splitter. It utilizes the NLTK to split the text into meaningful sentence-based chunks. And then we have the Spacy text splitter. It uses the Spacy's NLP models to split the text while preserving the grammatical structure. Now let's see how to split the documents for real. So from here, we have imported OS, OpenAI and systems, and then from the .env, if we have imported the load.env and the find.env, and we have set up our OpenAPI key. And then we have imported the recursive character text splitter and the character text splitter from the LangChain text splitter. So we will run this. And over here, we are mentioning the chunk size to be 26 and the chunk overlap to be 4 beforehand. And over here, we are initializing the art splitter with the recursive character text splitter, and we are initializing the chunk size and the chunk overlap. Then we are again initializing the C splitter as the character text splitter and chunk size to be the chunk size, and chunk overlap we have done before also. So we will run this, and here we have the first text and we will pass this. Then we have this R splitter for splitting this text one. So we'll see this. So you can basically see there is no difference. So for this, we have a different example and we will pass this and now we will see the result. And now you can see basically it has splitted the text, but the fact is we have a chunk overlap of 4, but it looks like 3. So let's see more examples. We are again passing this text number 3 and we will text split it with the use of art splitter, and you can basically see it has created A, B, C, D, E, F, G, H, I, J, K, L, M, L, M, N, O, P, Q, R, S, T, U, V, W, X, the W, X, Y, Z. Now let's apply the C splitter on the same example, and you can basically see it has again joined the whole text. This is nice. So here in again then the C splitter, we are adding a separator to be as the inverted commas. So we can see we have already got the result before, but here it is just separated with the inverted commas for more understanding. Here now it is the best time to actually pause and try out your own examples like this. But then we have a different example, and this time we have a paragraph. And let's now see the length of the text. It's 496 words. So we will now see the C splitter and the R splitter once again, and we will initialize it. This time we have the chunk size is equal to 450 and chunk overlap we don't have any, and we have a separator for the C splitter as the inverted commas. And in the R splitter we have chunk size as the same, no overlaps, and the separator should be a new line, 2 new lines, or a new line or a double inverted commas and everything. So let's just pass this. Now it's time to actually apply the C splitter over the some text we have generated. So you can basically see it is separated with the inverted commas. And here now in the R splitter, we will then apply it over the same text, and you can basically see the double inverted commas. So here what we have done is we have reduced the chunk size and we have added period to the separators. So let's now see. Now we can basically see the difference. And let's now see we have made a difference of, we have added this operators. And let's now see the difference. We have now loaded one PDF from the machine learning lecture 1, and we have called the loader class from pages. So here we are importing the character text splitter from the LangChain text splitter, and we have a separator of /n, and then we have a chunk size of 1000 and chunk overlap of 150. So let's run this, and then we can basically call the text splitter.split documents pages, and we will run this. Let's now see the length of the document, that is 77. And then we have a length of the pages, that is 22. And now we are importing the Notion directory loader, and then we are passing one Notion database, and then we'll load this. And then we are using this text splitter in the Notion database, and let's see the Notion DB length. And you can see it is 52. And then basically you can see the length of the documents, and then we'll see it is 353. Now basically we can actually split on the basis of token count explicitly only if we want. So let's now see that. So we are importing the token text splitter from the LangChain. Here now we are actually keeping the chunk size to be 1 and the chunk overlap to be 0, and we are passing it under the token text splitter. So here we again came with a one text and it doesn't make any sense, but it's okay. And then we are going to pass this text1 through this text splitter dot split and we'll run this. And then you can basically see it has splitted the whole text and it has also separated with the inverted commas. And then we are applying this to the pages, and let's now see the first document. And then you can basically see it is filled with page content, metadata that is containing the source, the lectures, the page we have. This is basically the field as I have already discussed. And then let's move on. And lastly, for the token wise splitting, let's see the metadata of the page. And you can see it is the machine learning lecture 1 PDF, page and fidelity. Now let's see the context aware splitting. So here we have imported the Notion directory loader and we have imported the markdown header text splitter. So here we have one markdown document and let's run this. And then basically we have these headers to split. That is first hash and then we have header 1, double hash we have header 2 and triple hash we have header 3. And here now we have this markdown splitter and we can basically see we have MD header splits equal to markdown splitter dot split text markdown documents. And then now let's see the MD header splits 0 that refers to the first document. And now you can basically see, hi, this is Jim. This is Joe, metadata header, title, header 2, chapter 1. And let's now see the second one we have. And this is Lance, chapter 1, header 3 section. Let's now see this on the new Notion database. Here basically we have this headers to split, header 1 and header 2. Then similarly we have this markdown header text splitter and we are using those headers to split on headers to split on. This is basically we are initializing it. So let's run this and let's now pass this first text and a markdown splitter split text and let's see. And let's now see the first document. And this is basically what we can see. Now guys, let's move on to the next chapter. So in this chapter, we will talk about the storing, the chunks, and vector stores and embeddings. So imagine you are reading a 200-page book and you want to remember the most important ideas. So instead of just memorizing every word, you highlight the key sentences and write them on the sticky notes. So these sticky notes are your chunks. So in the world of AI and large language models, especially in the Retrieval-Augmented Generation systems, we do something similar. We split the large documents into the small meaningful chunks or text. So this helps the model retrieve only the parts it needs to instead of reading the whole thing again and again. Now let us see why storing in chunks is important. So you might ask, why can't we just store the full document? And that is a valid question. So LLMs can only process a limited amount of text at a time. So giving them a whole book can overwhelm them or cause important parts to be ignored. And so storing information in the smaller chunks makes it easier for the model to find the relevant content quickly. And then the smaller chunks improve accuracy by helping the model focus on the specific details instead of giving vague answers. So let us now see what are embeddings. So now here's the cool part. How do we find the right chunk later? That's where embeddings come in. So embeddings are like the turning words into numbers that capture meaning. Think of them as GPS coordinates for ideas. For example, the words dog and puppy might be close together in the embedding space because they have similar meanings. So let's say we have a chunk. Python is a programming language used for the data science. So we convert this into a list of numbers or embedding like 0.12, 0.98, minus 0.34 and more. So this vector represents the meaning of that sentence, but not in words. So now let's move on and see what are vector stores. So okay, we have turned our chunks into embeddings, but where do we keep all these meaning vectors? In a vector store. So think of a vector store as a smart library. So instead of organizing books by titles, it organizes chunks by meaning. So when you ask a question, it compares your query's embedding with all the stored embeddings and pulls out the most relevant chunks. For example, you ask, what is Python used for? The system converts your question into an embedding and searches the vector store for the closest match, which might be the chunk we saved earlier. So, the answer is Python is a programming language used for data science, and boom, that's your answer. Let's now see how are they helping together, or why storing in chunks is so important. So putting it all together, you split the document into chunks. Then you generate embeddings for those chunks as well. And then you store the embeddings in a vector store. So when a question comes in, you generate its embedding. The vector store finds the most relevant chunks. And finally, the LLM uses those chunks to generate an accurate response. So this is how the RAG system works. They're not just smart, they're efficient. They don't try to memorize everything. Instead, they store what matters in the right format and retrieve it when needed. So let's now see everything in action.
So, to start, we will once again set the appropriate environment variables. So here we have already discussed how to load a document and how to split them just now. So now here we'll be working on with the same set of documents. So let's run this. So here now, after loading the PDF and all the documents, we are now planning to split them. So here basically we are importing the recursive character text splitter. So text splitter is equal to recursive character text splitter. We are initializing the text splitter. Then we have mentioned the chunk size as 1500 and chunk overlap equal to 150. So let's run this. So once again, if I have missed a point in the loading PDF, so there are a set of CS 229 lectures, and if you look closely, you will see we have duplicated the lecture 1 two times because of simulating dirty data. So that we can now see that we will initialize this text splitter. Now we can say this, we have created more than 200 chunks, 209. Now time to move on to the embeddings. Let's take our splits and embed them. We will use the OpenAI to create these embeddings. So we'll run this. Now, before trying with the real world examples, let's try out some other examples too. So we are planning to pass these 3 sentences over here. Sentence 1 is, I like dogs. Sentence 2 is, I like canines. Sentence 3 is, the weather is ugly outside. So we'll pass this. And now here, we can actually see that we have created 3 embeddings for 3 respective classes for the 3 sentences we have. So we'll run this. So we can now create an embedding class for each sentence. So we can import the NumPy to import them. We'll expect the first 2 sentences will be very similar. So we'll check that. And now we will be using this dot product to compare them. So the dot product in here multiplies the corresponding elements of the 2 vectors and then adds them up, giving a single number. It helps measure similarity between embeddings. Higher value means more similarity and lower value means less similarity. So we will run this. Now basically you can see that the dot product of the first and the second was quite higher respect to the first sentence and the third. So we can get a significant lower value. So now let's read the dot product between 2 and 3. And if you run this, we can see that it's almost the same. Now I will suggest you to pause the video and try out a few different examples and their dot products. So let's move on to the real world examples. It's time to create embeddings for all the chunks of the PDFs and store them in a vector store. So the vector store we will use here is Chroma. So let's import that first. So here we are importing Chroma database and we are importing Chroma from the Langton vector stores. And before we run this, LangChain has integration with lots of vector stores. We are using Chroma here because it's lightweight and in memory, which makes it very easy to get up and start with. There are other vector stores that offer the hosted solutions which can be useful when you are trying to persist large documents of data or persist it in the cloud storage somewhere. So then we are going to save this in the vector store so that we can use it for the future lessons. So let's create a variable called persist directory, which we will use later on at docs/chroma. So here, let's also make sure that nothing is there already. So here basically we have created the vector store. So we'll call the chroma from documents, then passing on the splits that we created earlier. So passing through embeddings, now this is the OpenAI embedding, and finally passing through a directory. And the directory is persist directory that we have created to store for the future use. So we will run this. Now we will take a look at the collection count. We can see that this is the same as that of the split that we did previously. So let's now start using it. Think of a question that we can ask. We know that this is a class lecture, so we can ask. So if there's any email address we can ask for regarding the class or anything. So the question we're gonna pass over here is there any email I can ask for help? So we are going to use the similarity search method over here, passing the question, and even k is equal to 3, which specifies the number of the documents that we want to return. So we will run this. And let's then check the length of the docs. Now that we will see the length, and it's 3 as we have specified. Now let's take a look at the content of the first document. It's in fact about an email address and is obviously an email we can send queries to. So now you can see that there is an email. This goes to the accounts that's read by all the TAs and me. So this is nice. So after doing this, let's be sure to persist the database for future use. So we'll persist it. So basically similarity search will give you 80% of the great results. But there are some edge cases, and now we are gonna discuss that only. Now let's ask a question. What did they say about the MATLAB? And we'll pass this. And we are trying that similarity search over here, and we're passing the k is equal to 5. Now let's see the first document. And then we'll look at the second one. And notice that we are getting duplicate chunks. So because of the duplicate machine learning lecture 1 PDF in the index, semantic search fetches all the similar documents, but does not enforce diversity. So docs 0 and docs 1 are identical. We can see a new ferial mode now. Let's pass one question. What did they say about the regression in the third lecture? So we'll pass this. We can check this because we have information about metadata about what lectures they came from. So we are using the similarity search, passing through this vector DB, and we are keeping the case values equal to 5. So let's loop over this document and print the metadata. So we can see a combination of results, some from the lecture 3 and some from 2 and 1. The reason it is failing is that the third lecture and the fact that we want documents from the third lecture is a piece of structured information, but we are doing a semantic lookup based on the embeddings, where it creates an embedding for the whole sentence and is probably a bit more focused on the regression. So let's now look at the fifth document. The one that comes from the first lecture, it does refer to the regression. So if it is picking up on that, but not on the fact that it's supposed to be querying documents only related to the third document, because again it is a piece of structured document. So it is a good time to pause and truly figuring out some more questions and try changing the value of k. So in this lecture we have seen the basics of semantic search and also the failure modes. Let's move forward in the next part and try to address those failures and retrieval too. In this lesson, we will dive deep into the retrieval and few more advanced methods for overcoming the edge cases. So let us understand what is retrieval in RAG. So
In RAG, retrieval refers to fetching the relevant documents or data from a knowledge base like a vector database, or the local files to answer the user queries. It helps in searching, filtering, and retrieving information efficiently. Now, let us move and see where retrieval is used. So, it is used in the chatbots with memory. For example, retrieving the past conversations. Then we have question answering system. That is, for example, retrieving the FAQ answers. Then it can be used in the AI powered search engines. That is for the semantic search. So the techniques we will be talking about today are new to the market. The first one we will be talking about is maximum marginal relevance. That is, the MMR is a smart way to select the diverse and the relevant information from a large set of documents. So instead of just picking the most similar results, it balances the relevance and diversity, ensuring that the retrieved results are not too repetitive. So MMR is used in the Retrieval-Augmented Generation, that is the RAG, to improve the search results by selecting both the relevant and the diverse documents. So imagine searching for the best AI tools. So without MMR, you get the 5 results about ChatGPT, too similar. But with MMR, you get the results about ChatGPT, Gemini, Claude, Midjourney, and Copilot. So let's now move on to the second one we will be talking about is LLM-aided retrieval. LLM-aided retrieval is a smart way to improve the search results by using a large language model to refine or guide the retrieval process. So instead of just fetching documents based on the keyword similarity, the LLM helps in the better query understanding, ranking, and selecting the relevant information. For example, without LLM-aided retrieval, a search for the AI in marketing may retrieve random AI articles. So with LLM-aided retrieval, the LLM understands the intent and retrieves the specific articles on AI tools for marketing. So let's now move on and see the demo. So let's see all the techniques in action. So we will start with loading the environment variables as we always do, and then we'll run this. So let's then import Chroma from LangChain vectors. We will also import OpenAI embeddings, and we will also create this persist directory we have created before, the docs Chroma, and we will run this. We will now create embeddings. Embeddings equal to OpenAI embedding, vector Chroma, and then pass this persist directory and embedding function. So we will run this. So now we'll try to print vector db dot collection dot count, and we'll run this. So after looking at the collection counts, we can see this is 209 documents that we loaded before. So let's now begin with maximum marginal relevance MMR. So we have all this text that got loaded and all are about mushrooms. So we'll create a small database equal to Chroma dot from text, and we'll pass text comma embeddings equal to embedding. So this is type of a toy example, and we will run this. So I have a different question. Tell me about all the white mushrooms with the large fruiting bodies. So I'll run this, and we'll create plugin called this smalldb dot max marginal relevance search. We will pass the question, then k is equal to 2, fetch. Make sure you give the correct code, and we'll run this.
So here, if you see, we have still k value as 2, but fetch k is equal to 3 to fetch all the 3 documents originally. So now let's go back to a question, a previous lesson where we asked about MATLAB. So the question is, what did they say about MATLAB? And we have the vector similarity search over here, and the case value is 3. So now we'll basically compare docs ss 0 dot page content and we will run this, and we will again, basically I'll copy this and I will change 2 to 1. Now we can actually see that both are the same. Now we will use MMR to actually find out the difference. So let's write docs MMR first document dot page content and we will copy this, paste it here, and we'll make it as 1. Now the second one is different. It's getting some diversity in the environment. Let's now move on to the next part. We have a different question again, and we'll try to run this. So we are here again using the vector DB similarity search, and if you see, it is the third lecture over here. So we'll try to run this. Now if you see this, that you will understand that it got retrieved, that is exactly like the initial. So now we are going to use self-query retriever. So I'm importing OpenAPI and self-query retriever and attribute info. Let's run this. So here again we are specifying the metadata attributes like the name, the description and the type, and if you see the difference, the page from the lecture, and here in the description it is the lecture, the chunk is from should be one of the documents from this. So let's run this. We will now specify it more and use LLM as OpenAPI model, and we will give retriever as self-query retriever from LLM and vector DB and everything, and we will also here verbose is equal to true. So we will run this. So here we are basically retrieving the relevant documents and passing the question, and it is okay, and we'll print the metadata. This can be ignored and you can actually find out the metadata. So there are some additional tricks over here for compression. That is another approach for improving the quality of the retrieved documents is compression. So information most relevant to a query may be buried in a document with a lot of irrelevant text as well. So passing that full document through your application can lead to more expensive LLM calls and poorer responses. So contextual compression is meant to fix this. So I'll import contextual compression retriever and we'll run this. Here we are passing this pretty print documents through the documents, and we are even giving all the specifications of the double new line, page content and everything, and we will run this. So here we will wrap our vectors stored. So we'll run this. We can now create a compressor with the LLM chain extractor as well. So we'll run this. We can now create the contextual repression retriever and then the best retriever from the vector store. And now we are passing the question and we'll run this. Now we are passing the question, seeing the output, you can find out that the documents are shorter than the normal one. And they have some repeated stuffs as well. So it's not worth nothing that vector DB is not the only kind of tool to retrieve documents. The LangChain retriever abstraction includes other ways to retrieve documents such as TF, IDF or SVM. So let's see. We will begin with loading the environment variables like we always do, and we will run this, and then
we will see loading the PDF, and then we are using the recursive character text splitter to split the text, and we are specifying the chunk size, the chunk overlap, and finally splitting it. So after splitting is done, we will be using the retrievers SVM retriever and TF-IDF retriever, and we will run this. And then finally, we will ask this question, what are the major topics for this class? And we will basically run this. Now you can see the page content. Let me just check about what questions you have right now. So if there are no questions, I will just, it has given it. So now we are using the TF-IDF retriever, and let's run this. So this is the right time to pause and try your own examples. And now down the line in the next lecture, we will see how we can ask questions and get the relevant answers. So in this lesson, we will learn how to extend the normal agent to handle multiple documents and increasing the degrees of complexity. So now, initially we'll begin with setting up the OpenAPI key. And secondly, we will import the Nest Essentio. And then the first task is to set up our function calling agent over 3 papers. So we do this by combining the vector summary tools by each document into a list and passing it to the agent so that the agent actually has 6 tools in total. So here we have downloaded 3 papers from the Clear. So this includes the MetaGPT for the last time, and this also includes the long LoRa as well as the self-RAG. So next we will convert each paper into a tool. So this is basically a helper function. That is the gap doc tools, which automatically builds both a vector and index tool as well as a summary index tool over a given paper. And the vector tool performs the vector search and the summary tool performs the summarization of the entire document. So for each paper we are getting back both vector tools and the summary tools. So here we'll run this. So then we will define the 3.5 Turbo from the OpenAI as the large language model of our choice. And now if we run this, it is basically the GPT 3.5 Turbo. So if we really take a quick look at the number of tools that are going to be passed to the agent, we will get 6. Because we have 3 papers and 2 tools for each paper, a factory and a summary tool. And the next step is to construct our overall agent worker. And it includes all the 6 tools as well as the large language model that we pass out. And we are able to ask questions across these 3 documents or within a single document. For now, let's ask a question. Tell me about the evaluation dataset used in the long LoRa, and then tell me about the evaluation results. And we have got the answer that one of the eval datasets uses the feature of 19 test split. We are able to look at the eval results for our long haul models. The next question is, give me a summary of both the self-RAG and the long LoRa. So this will basically allow us to do the summarization of the 2 papers. So first, we call the summary tool for the self-RAG with the inputs of its name. So we will run this. And you can basically see added user memory. You can basically see added user message to the memory. Then we have the calling function. Then we have the output. Then again we are calling function, and then we have the output. And this code defines the tool list, URLs and the papers. So the URLs list contains 11 links to research papers in the PDF format from the Open Review website, while the papers list consists of the corresponding file names that likely represent the downloaded versions of these papers. So here each URL in the URLs list maps to a specific file name in the papers list, suggesting that these names might be used to save the downloaded files. So this setup can be useful for automating the downloading process, keeping track of the files, or referencing papers by their assigned names. So this code basically processes a list of the research papers by extracting the specific tools for each document using the getDocTools function. So it begins by importing the getDocTools from the utils module and path from the pathlib for handling the file names. An empty dictionary paper to tools dictionary is initialized to store the mapping of each paper to its respective tools. The code then iterates through the papers list, printing a message to indicate which paper is being processed. For each paper, it calls the getDocTools, passing the paper's file name and its name
file name without the .pdf function. So this function returns the two tools, that is the vector tool likely for converting the text into embeddings for the NLP task, and summary tool which might generate the summaries of the paper. So these tools are then stored in the dictionary with the paper file name as the key and the tools as the value. So this setup enables efficient document processing, allowing for easy access to vectorized representations and summaries for the research paper. Now basically you can see the output. So this code creates a list called the all tools that collects of the tools from the paper to tools dictionary for every paper in the papers list. So it uses a nested list comprehension, which means it goes through each paper in the papers, retrieves its associated tools, a list of the two tools stored in the paper to tools dictionary, and adds each tool to all the tools. So as a result, all the tools become a single list containing all the vector and the summary tools for every paper rather than keeping them grouped by paper. So this approach makes it easy to access and process all tools together instead of dealing with them paper by paper. So here this code creates an object-based index and retriever for the tools stored in all the tools using the vector stored index from the llama-index.core library. So the object index from the objects function takes all the tools and organizes them into a searchable index. So the index CLS is equal to vector stored index argument specifies that the indexing method should use a vector-based retrieval, meaning each tool will be converted into a vector representation for the efficient searching. So this setup allows the quick retrieval of the relevant tools based on the similarity searches, making it useful for the tasks like finding related tools based on the user queries. Now this code object retriever is equal to object index dot as retriever is creating a retriever object from the object index, which likely represents as index collection of data such as documents or embeddings. The asRetriever method converts this index into a retriever, following it to fetch the relevant results based on the similarity. The parameter similarity top k equal to 3 ensures that when a query is made, the retrieval will return the top 3 most similar results based on their relevance. So this is useful in applications like search engines, chatbots, or recommendation systems where retrieving the most relevant information is important. So here the core tools equal to object retriever is asking the retriever to find the relevant information related to the given query. The retriever searches through the index data and retrieves the most relevant results based on the similarity. Since object retriever was configured to return the top 3 similar matches, it will return up to the 3 pieces of relevant information. The retrieved results are then stored in the tools variable, which can be used for further processing, such as displaying the information to the user or using it in an AI model. So this process is commonly used in the AI-driven search systems, chatbots, and question answering application to fetch the relevant data efficiently. So here the core tools to .metadata is accessing the metadata of the third retrieved result from the tools list. Since the tool stores the results returned by the object retriever.retrieve, each item in the tool contains both the retrieved content and the additional metadata. So metadata typically includes the extra information, such as the source, timestamp, author, document ID, or other attributes, and that describe the retrieved data. So by using tools.metadata, you are specifically extracting the metadata of the third result, which can be useful for understanding whether the retrieved data came from the adding context to the results or not. So the given code over here is setting up an AI-powered agent that can answer questions based on the retrieved information from a collection of papers. So first it imports the function calling agent worker and the agent runner from the llama index code.agent. Then it creates an agent worker using the function calling agent worker, which takes the object retriever as the tool for retrieving the relevant information and LLM to process and generate responses. So the system prompt ensures that the agent always relies on the retrieved data instead of the prior knowledge. So finally, agent is equal to agent runner wraps the worker inside the agent runner, making it easier to manage and execute the agent's task. So this setup allows the agent to intelligently retrieve and generate answers based on the predefined knowledge base, making it useful for the research, document analysis, and question answering applications. So this code is making the AI agent answer a query about the evaluation dataset used in the MetaGPT and how it compares to the SWB bench. The query function sends this question to the agent, which then retrieves the relevant information using the object retriever and processes the response using the language model. The retrieved and the generated response is stored in the response variable. So finally, the print str response converts the response into a string and displays it. So this allows the AI agent to provide a well-structured answer based on the available documents, ensuring an informed comparison between the two datasets. So this last but not the least code AI agent analyze and compare the two research papers, Long Laura and the Loft Q. The query function sends a detailed question asking the agent to first analyze the approach used in each paper and then compare and contrast them. The agent retrieves relevant information using the object retriever and processes the response using the language model. So the generated response is stored in the response variable. Finally, the retrieved and the analyzed answer is stored in the response variable. This setup helps in extracting the insights from the research papers efficiently, making it useful for the academic research, technical analysis, and AI-driven summarization. Now you can see that it has generated the output. In the next lesson, let's conclude this whole course. So lastly and finally, we have a conclusion over here. And the conclusion basically focuses on the future of RAG. So as powerful as RAG is today, its future looks even more promising. So in the upcoming years, we can expect the smarter retrieval, that is the more accurate retrievers that consider the semantic nuances, user preferences, and intent, not just keywords. Then we have multimodal RAG, that is integration of not just text but also images, audio, and video into the retrieval and generation process. Then we can even expect the personalized agents, that is the systems that learn from the user feedback loops in real time, delivering more relevant and personalized answers. Then we can even expect the memory augmented RAG, that is incorporating the long-term memory into agents so they can retain the context across sessions. Then we can expect the low latency, that is scalable RAG, that is optimizations in storage and retrieval that allow the RAG to work seamlessly even at the massive scale and speed. So RAG is evolving fast, from powering search engines to enhancing the customer support, healthcare, finance, and education. So as these systems become more fine-tuned and grounded in the accurate and the real-world knowledge, they will bridge the gap between the static data and dynamic, intelligent responses, paving the way for the next generation of AI. So guys, congratulations on completing the RAG for the Beginners course. You have now built a strong foundation in the Retrieval-Augmented Generation by learning what RAG is, why it matters, and how it powers the real-world applications. From understanding the core components like the query encoder, retriever, re-ranker, knowledge base, and generator to hands-on demos in the document loading, chunking, storing with embeddings and vector stores, and building a multi-document agent, you have gained the practical skills to apply RAG effectively. So as you move forward, continue experimenting with your datasets and refining your pipeline to unlock the full potential of RAG in creating the smarter, context-aware AI systems.
Imagine a world where AI can access and use external knowledge on demand, instantly generating the most accurate, up-to-date responses. Sounds like something from a science fiction novel, right? But, well, it's not science fiction anymore. These techniques makes reality possible. In this video, we are diving into two cutting-edge methods for enhancing AI-driven responses. The first one is Retrieval-Augmented Generation, and the second one is Cache-Augmented Generation. So guys, watch this video till the end to learn more about it. So let us start with first understanding what is RAG. RAG stands for Retrieval-Augmented Generation. It is a technique which is used in large language models to enhance the quality of their generated responses by incorporating external knowledge. Instead of relying solely on the data the model is actually trained on. Now, RAG dynamically retrieves relevant information from an external source, such as it could be database or search engine, and it uses that to augment the model's understanding, thus helping it to generate more accurate and more informed responses. Now, you would be wondering how exactly RAG works. So you can see I've created a certain diagram all over here, and we are going to understand certain key parameters. Now, there are three parameters for understanding RAG. The first one is a retrieval. So when a user provides a query, the system actually searches through an external knowledge base, like it could be a vector database or index, and then it retrieves most relevant documents or text snippets related to the query. The next process is augmentation. Here, the retrieved documents or informations are appended to the user's original query. This actually provides additional context to the model, which helps in forming a more informed and detailed response. And finally, you get generation. So the language model processes the augmented query, which is the original query plus the retrieved documents, and generates a response based on both new context and its internal knowledge. Now, let us try to understand with a real-world example. Now, imagine you are running an e-commerce platform, and a customer contacts your support team with a question about the status of their recent order. So instead of manually searching through support tickets or frequently asked questions, RAG systems can help to streamline the process. And here, how it is going to do it. So the RAG system uses two components, the retrieval model and the generation model. First, the retrieval model searches the database or relevant documents to find the most pertinent information, such as it can be tracking details or past communication. It then essentially retrieves facts from the most accurate or recent sources like order status, shipping information, or delivery timelines. Next, what is going to happen? The generation model uses this retrieved information to generate a natural language response to the customer. It ensures that the answer is not only accurate but also conversational, and it is tailored to the user's query. For example, like you might get a response something like this, so that your order number #12345 was shipped on March 20th and it is expected to arrive by March 23rd. And there will be a link, you can track it here. So you can see like how this integration of information retrieval with natural language generation is highly efficient for both businesses and customers. And it is reducing the workload on support agents while providing real-time, precise, and human-like responses to the query. So guys, in broader sense, you can imagine that RAG has applications in industries like legal. So guys, in broader sense, you can think of RAG has applications in industries like legal research, content creation, healthcare, where it can quickly generate reports, articles, or patient-specific advice based on vast repositories of data, and all thing in real time. Now, let us understand some of the key features of RAG. So guys, the first feature is real-time retrieval. So guys, RAG enhances the language model by fetching relevant information from external sources like database or vector store, in real time ensuring the model has access to up-to-date information during inference. Next is context augmentation. So here, once the relevant documents or data are retrieved, they are appended to the user's input query. This enriched context helps the model generate more accurate, informative, and contextually aware responses. The third one is dynamic knowledge integration. Here, RAG integrates external knowledge dynamically, which means that it can handle situations where the model's internal knowledge might be outdated or insufficient. So here, the model can rely on real-time data for external sources to make its response more accurate. Fourth one is that you have a fact checking. Since RAG fetches real-world documents to augment responses, it also offers a high level of factual accuracy, reducing the chance of hallucination, which means that incorrect or fabricated responses, when you're comparing it to models who are relying solely on training data. And finally, you have flexible query handling. So guys, RAG can handle complex multi-step questions by retrieving and combining information from various sources. This makes it suitable for tasks like multi-hop reasoning, where multiple pieces of information are needed to answer a query. So guys, these features make RAG a powerful method for integrating external knowledge into language models, improving models' accuracy, relevance, and ability to handle diverse and dynamic queries. Now, let us try to understand about what is Cache-Augmented Generation. So guys, CAG is an alternative method to Retrieval-Augmented Generation. Basically, it is used for incorporating external knowledge into large language model. So unlike RAG, which retrieves information from external database in real time, CAG preloads a curated set of relevant answers, enabling faster and more efficient inference without the need for retrieval step during runtime. Now you'd be wondering, how does CAG works? So CAG works in following ways. So guys, first it preloads any knowledge. So before the model is used for any queries, a curated set of documents or knowledge is loaded into the model's memory, typically via a process called as pre-computing. And this knowledge is stored in a format called key-value cache, where intermediate states of a knowledge are stored and can be accessed rapidly during inference. Then there is KV cache. This is where the knowledge is stored in the model's memory, making it available for quick reference during any query. So instead of fetching data on demand, the model uses preloaded knowledge stored in this cache. Then here is streamlined inference. So when a user asks a question, the model can quickly reference the relevant knowledge which is already stored in its cache, allowing it to generate a response without waiting for any external retrieval. So you could see we have mentioned preloading knowledge is required, then pre-computing happens, then storing the given key value cache, then we take the inference, and you can also do the cache reset, which is optional. Now, with this, there are certain benefits like you get no retrieval latency. Like unlike RAG, CAG is actually eliminating the need for real-time retrieval. So you get faster response times. Next, you also get a simpler pipeline. Since there is no need to maintain an external database or perform retrieval steps, the system is simpler to manage and require less computational overhead. And finally, you get unified context. The model can process all the relevant information at once, enhancing reasoning abilities, especially for multi-hop questions, like the questions which are requiring information from multiple sources. But still, there are certain challenges which this model, like the context size limit, the model's context window is finite only, so only a limited amount of information can be preloaded. Here you get upfront computation, where like pre-computing and storing KV cache also requires significant upfront computational resources. And finally, you get stale data, meaning that if the knowledge base changes frequently, means like breaking news or any real-time event, then the cache may become outdated, and updating the cache can be an additional overhead. So with all the plus, there is also some minus with this, but that's how exactly CAG is working. Now you could see we have mentioned certain key features like we have preloaded knowledge, we have KV cache, we get faster inference because here we are eliminating the need for real-time document retrieval. Then you are also getting no retrieval latency. So like what happens in RAG, like where each query is going to trigger a retrieval process, and that is going to introduce a latency. So here CAG's approach ensures that there is no delay caused by waiting or for external information. Then it is consistent across all queries, meaning that since the model references the same preloaded cache for every query, it also ensures consistent responses across multiple interactions. So these were some of the key features of CAG. Now let us discuss about some of the key differences between RAG and CAG. So we have chosen 4 parameters to assess the differences. The first one is data retrieval. So if we look into RAG, so we get to know that RAG is performing a real-time retrieval of documents or information from any external source. It could be a vector database, at the time of the given query. Then you could see, if we talk about CAG, then here CAG actually preloads the entire knowledge base or relevant documents into the model's memory upfront. So there is no need for real-time retrieval during inference. Next one is latency. So RAG has higher latency because it retrieves data in real time before generating the answer. so it can slow down response times. Then next is CAG. So CAG means lower latency because all the required knowledge is preloaded and stored in the cache. So responses can be generated with much faster without waiting for any external retrieval. If we talk about systems complexity, I would say RAG is more complex since it requires maintaining an external retrieval system, which could be a database or an index, it could be anything, and it continuously updates the documents or knowledge base. Whereas if we talk about CAG, it is kind of simpler, it avoids the need for external retrieval systems, and it relies on a pre-computed key value cache, making the system easier to maintain. And finally, if we talk about data freshness, guys, then we all know that RAG can handle dynamic, frequently updated data since it fetches the latest information in real time. But if I talk about CAG, guys, it is best suited for static or stable knowledge bases. Since the data is already preloaded, it might not reflect the most recent changes unless the cache is updated periodically. So these differences make RAG ideal for scenarios where data is constantly changing or too large to load into a memory. While if we talk about CAG, it is more efficient for use case with stable and well-defined knowledge. So I hope so, guys, you would have got a brief idea regarding RAG and CAG and their key differences. So that was all for today's video. I hope so you would have enjoyed our today's video on RAG versus CAG.
Hey there, imagine you have a robotic librarian. This librarian's job is to help you find specific information across the internet. But here's the catch. The librarian doesn't have all the answers. So when you ask, what's the most important information on AI agents, the librarian doesn't just pull answers from memory. Instead, they go on a quest to find the right books, articles, and papers online, gathering only the most relevant pages that will help answer your question. This process of searching and collecting information from the internet is known as web crawling. But there's more. After the librarian gathers all these books, the next thing they need is a way to organize and understand what they have collected. That's where RAG, which is Retrieval-Augmented Generation, comes into play. Think of RAG as the librarian's brain. It doesn't memorize everything they have read. Instead, they take all the data and generate an accurate, meaningful answer by finding the most relevant parts. So while web crawling is about gathering information, RAG is about organizing and generating the right answer from that information. Now let's bring it all together. Web crawling and RAG are like the ultimate team. Web crawling helps the librarian gather the right data from the internet, and RAG ensures that the librarian can give you the most accurate, helpful, and expert answer. Crawl for AI is a tool that helps the librarian gather this information quickly and efficiently, turning raw website into something that AI can understand. In this video, I'm going to show you how Crawl for AI can supercharge this process. You learn how to separate scraped data from websites, convert it into a format that's easy for AI to understand, and set it up for RAG to use. This will help your AI become an expert in anything, whether it's AI agents, e-commerce stores, or any domain you want. I'm also going to walk you through the entire process step by step, from installation to scraping websites and preparing the data for RAG. So without any further ado, let's get started. Alright, so let's start with the basic and first understand what exactly is web crawling. Imagine you're a reporter covering a big event. Instead of attending every session or speaking to every guest by yourself, you send a robot to gather all the news for you. The robot visits every corner of the event, notes down all the important details, and then brings them back for you to report on. This robot is necessarily a web crawler. So in simple terms, web crawling is the process where a computer program or robot automatically visits websites, extracts the data, and brings it back to you in a very structured way. It saves it tons of time by collecting a lot of information from a bunch of different sites, that too in one go. For example, let's say you want to track the latest product prices on different e-commerce websites. So instead of manually visiting each website to check the prices, you can just use a web crawler to automatically visit the website and then extract the prices for you. And here's why web crawling is important in RAG. So when you're feeding your AI knowledge, you need data from the web. Web crawlers help gather that data in a way that makes it useful for your AI. The more data your AI can access, the smarter it becomes.
So now that you have understood what is web crawling, let's understand what is RAG, which is Retrieval-Augmented Generation. So this might sound a little complicated at first, but trust me, we'll make it super clear. Imagine having an AI assistant. Normally, this assistant knows a lot about general topics, but when you ask it about something new or specific, it's just guessing. It's like asking someone who knows a lot of general facts but hasn't read the latest book on your favorite subject. RAG solves that problem by allowing the AI to retrieve information from external sources like websites, documents, and then generate a response based on that information. It's just like giving your assistant a superpower where it can look up answers on its own rather than just relying on what it already knows. And the best part is, it helps your AI become an expert in specific fields that it wasn't familiar with before. Let's say, for example, imagine you're building a customer support bot for a new product. Normally, the bot wouldn't know much about your product if it's new or niche. But by using RAG, you can feed it all the product documentation and facts, and the bot will be able to provide accurate, detailed answers just like an expert who's been trained on everything related to that product. So now you must have understood what exactly is RAG. Let's switch our gears and understand how web crawling is used in RAG. So here's the connection. Web crawling is the first step to RAG. If you want your AI to become an expert in any particular subject, it needs access to detailed information. And that's where web crawlers come in. They help gather the data that your AI will use to generate smart answers. For RAG to work, the AI has to be fed the right information. You can use web crawlers to visit different websites, gather the information you want, like product details, user manuals, or technical blogs. And then you can store that information in a format that the AI can understand. Here's an example. Let's say you're building a chatbot that helps people understand a specific programming language. You can use a web crawler to scrape all the tutorials, guides, and documentation available online about that language, and then you can feed it into the AI. Now, when users ask about the bot questions, it can answer them with the most up-to-date relevant information. So now you must have understood how is web crawling used in RAG. We will understand in the next topic what is crawl for AI and how does it work. So now let's start with what is crawl for AI and how does it work. So we have head over to this website. It's open source. You can just directly access it. So basically, Crawl for AI is the #1 trending GitHub repository which is actively maintained by a vibrant community. It delivers blazing fast AI-ready crawling tailored for large language models, AI agents, and even data pipeline. It's open source, flexible, and built for real-time performance. Crawl for AI empowers developers with unmatched speed, precision, and deployment ease. Also, the latest update is out over here, so you can just simply check that. So these are the major highlights. First of all, it's deep crawling system. That is, you can explore websites beyond initial URLs with just 3 strategies, which is the BFS, DFS, best first strategy, page limiting. So these are the new features it has allowed. You also get the option of multiple crawling strategy as well. Now you might be thinking that why should you consider using Crawl for AI? So first of all, it's built for large language model. That is, it creates smart, concise, markdown optimized for RAG and fine-tuning application. It's very fast. It delivers results 6 times faster with real-time, cost-efficient performance. It's flexible browser control. That is, it offers session management, proxies, and custom hooks for seamless data access. It also has heuristic intelligence, that is, it uses advanced algorithms for efficient extraction, reducing reliance on costly models. It's also open source and deployable, that is, fully open source with no API keys, ready for Docker and cloud integration as well. So now let me tell you by giving an example that why is it so important to use Crawl for AI. So when I just click on the website view page source from here, so from here you can just extract the raw HTML from it, but just look at this. It looks a complete mess, and as a human looking at this, it's very hard to actually extract the useful information. So probably it would be even harder for the large language model to extract information from here. And so one of the most important things that Crawl for AI does is that it takes this ugly HTML that we get when we visit the raw content of a web page, and then it turns into a markdown form, which is actually even human readable format, like a super clean way to represent a web page and all the information that we see when we're typically visiting a UI. Let's suppose when you're visiting a UI like this, just in something that's all text based, so we can give it to a large language model and just for them to understand it better in general. And one more thing is that it handles a lot of things under the hood, like proxies, session management, things that are not easy to handle. So it's not like you can go and make your own version of Crawl for AI very easily, because you know how to use the request model in Python to pull the HTML from websites, and it's also completely open source and very easy to deploy. They even have a Docker option, which I already told you before. So you can also use them to deploy using the Docker option and the Docker deployment. So right now I'll not be focusing much on the Docker part. So we'll just get started with the installation part for Crawl for AI here. So first thing is that you need to just install the package from here. So I'll just copy the command and just open terminal. And from here, you can just copy paste, and it's saying that you're about to paste, which contains multiple lines. So yeah, I have already installed Crawl for AI in my system, so it will automatically take the other commands as well to set up and to pre-install the previous versions as well. So I'll just click on paste anyway. So it is installing the package now. It will just take hardly seconds to install everything. So as you can see, it has successfully installed the Crawl for AI. It's mentioned over here. And now it is installing the pre-release versions. Now we are running the post-installation setup for Crawl for AI using this particular command. Now to verify your installation, you would have to give the command of Crawl for AI doctor, and we'll just click enter. So it is running a Crawl for AI health check now, and it's testing all the crawling capabilities of this particular Crawl for AI. So now as you can see, all the crawling tests has been passed and we have successfully installed Crawl for AI. Now if you encounter any browser related issues, you can also install them manually using this particular command from here. And now you can run a simple web crawl using the Python. Or you can also use a new command line interface. Let me show you my own version of this particular Python from here in the VS Code. We've got a VS Code from here and we have all the source code from here. And this is the crawl singlepage.py. This is the program which I have shown you before. That is this particular example, how to do a simple web crawl using Python. Also, you would need to install the Visual Studio installer to actually integrate all the tools, C++ files, CLI and everything. Yeah, so here this is a simple code to web crawl for this particular URL, which is Pydantic. So I'll just show you what exactly is this particular AI tool and why are we scraping that. Okay. So basically, Pydantic AI is a Python agent framework which is designed to make it less painful to build production grade application with the help of generative AI. So why should you consider using Pydantic AI? Because it's built by the Pydantic team, it's model agnostic, Pydantic log file integration, it's type safe, Python-centric design, structured responses, dependency injection system, stream responses, graph support, and many more. So when you just click on the view page source from here, so you can see this is the source code, the HTML code from here. And now we will be just scraping all the information of this particular website into our code. So this will give you all the information by running this code. So to run this, we'll just go to our terminal from here and just click on Python and enter the script name, which is one crawl single page PI. So as you can see, so within second it has given me all the website, the content, the structure of all the code from here. That too in such a readable format. You can see the introduction is here included, why, what is the Pydantic AI framework, everything using the code and everything. So as you can see, we have scraped all the information for that particular page script over here, which was this particular script for Pydantic AI. Alright. Now, one more thing, that what you see here in the navigation bar, the different pages. So you would need to write code for differently for each particular page. Now, if you want to integrate all the pages in one go, here comes the introduction of sitemap. So what sitemap will do is it will actually give you a full website structure which will contain all the web pages and all the pages which you see on the website, and then you can simply scrape the data from there. So to activate that, just click on backslash and just enter sitemap.xml for any website you want to scrape for. Yeah, so as you can see, the XML file is ready now, and this XML file does not have to appear to give any style information associated with it. The document tree is shown below. So this is the sitemap, as you can see. This basically gives you the entire structure of a website of all the pages that exist for the Pydantic AI documentation right now, which I have already shown you before. Now I can do the same thing for the Crawl for AI documentation as well. So let's suppose if I want to do it for Crawl for AI. So from here, you just head over to the documentation site for this Crawl for AI. And these are the different navigation pages from here. And we'll just write backslash sitemap.xml to see the sitemap structure of this. Yeah. And so from here, you can just scrape the data, and these are all the information of all the different pages. So yeah, in the same way, you can do this with the most of the websites, mostly e-commerce stores, if they are built with Shopify, WordPress, because they would have contained more number of pages, right? Even the general website have this for search engine optimization also, for crawlers. I mean, a lot of websites want you to crawl them because they want their information very widespread. Like if I'm building an AI agent framework, then I would definitely want people to crawl this and build agents around it, because then they're using my framework and it's just more accessible. Now, one more thing, if you're much more curious about how can you scrape a website, there's a lot of ethics behind it. So what you can do is, you can just simply go to any general websites. Let's suppose youtube.com. Just type youtube.com and then add this backslash robots.txt. Yeah, so as you can see, this is the robots.txt file for YouTube, which is created in the distant future, the year 2000 after, and the robotic uprising for the mid-90s, which wiped out all the humans. And this is the user agent, and this is the disallow function or whatever it is. So first of all, for any website which we are scraping, you can use the robot.txt first before, and then you can go ahead, like GitHub is also a good example to scrape, and this will give you all the permissions. I mean, how can you scrape this and what are the ethics you should follow for scraping that particular website. You can also similarly check for github.com also. So we'll just check github.com backslash robots.txt. Okay. Yeah, so this is the particular txt, robots.txt documentation for GitHub. So it has given you the permission if you would like to crawl GitHub contact, you need to contact to this particular support team from here. Then it is also mentioned that we also provide an extensive API and the username and the crawl delay and everything from here. Now talking about the URLs that you can add to pretty much any website. So you can just do backslash robots.txt or the backslash sitemap.xml. And so we are going to do encode and pull this sitemap, and then we are going to extract every single URL and then feed it to Crawl for AI. And we want to do that very efficiently, because right here we are just going to pull every URL, then looping it and going through one at a time. So let's just check in the VS Code here. All right, so we had got this information for this particular page, right? The structure, website structure. So you can do it in for different pages as well. So let's do for this crawl doc sequential.py. And so this is a simple code to crawl the website from here. So you can create the crawler by using this particular function from here. And then you can just get the Pydantic doc URL from here, and just we are giving the sitemap XML to get the URLs. The sitemap URL is mentioned over here in the code. And then you have to extract all the URLs from the sitemap, and the namespace is usually defined in the root element also. Now, if you want to extract the website from here, again, we'll just go in the terminal. And again, we have to run the same thing and just enter the name of the script from here, which is to. So it is giving that it has found 63 URLs to crawl for the sequential crawling with the session reuse. So it has successfully crawled the website from here. It has also given error. The markdown v2 attribute is deprecated and has been removed. So please use the markdown instead, which now returns markdown generation result with the following properties. You just get the details for whatever crawl you're doing for that particular website and what changes you have to make in order to crawl. So now let us also understand some advanced crawling techniques with Crawl for AI. So as you know, with Crawl for AI, you can also crawl multiple pages in parallel, which makes the process a lot more easier. We have the option here. Let's check the multi URL crawling. Okay. So instead of visiting one page at a time, then Crawl for AI will allow you to explore websites in different ways using techniques like breadth first search, depth first search, and these strategies will help you to crawl efficiently and make sure you get the most relevant pages. So basically, the breadth first search will explore websites level by level, scraping pages in the same level before moving on to the next level. Talking about DFS, it will dive deep into the website and scrape each section before moving on to the next branch. Best first, which will use scoring to prioritize important pages first. So as you can see, so when crawling many URLs, this is the basic which you have to use. Use Arun in a loop, simple but less efficient. If you use this particular function, then it will efficiently handle multiple URL with proper concurrency control also. And for best results, you can just customize the dispatcher behavior for your specific needs, memory management, rate limits, etc. So why are we using dispatchers? Because it's adaptive, rate limiting, real-time monitoring, and flexibility. So these are the core components of using the rate limiter function from here. So basically, the rate limiter is a utility that will help manage the pace of requests to avoid overloading servers or getting blocked due to rate limits. So it operates internally to delay requests and handle retries, but can be configured using its constructor parameters. So these are the parameters for rate limiter, which is the base delay. Then we have the example also, the base delay. Suppose this delay could be randomly chosen between 2.3 seconds and 4.1 seconds. We also have an example for initializing and using the rate limiter in your project. This is the example from here. We also have the crawler monitor, and the crawler monitor will provide the real-time visibility into crawling operations. So these strategies will ensure that Crawl for AI extracts the most important data for your AI quickly and effectively. So when we had crawled for this particular tool, sequential PY, so it had to crawl all of them sequentially so that we'll get into parallel. And by using parallel processing, you can make it much more faster and even within seconds. Now the third code which we have is for the crawl docs fast.py, and here also they can append the parent directory to the system path by giving this particular command. And you can also create the crawler instance by using this function. And then we can chunk the URLs in batches of max concurrent. It will fetch all the URLs with the Pydantic documentation and will use the sitemap to get all the URLs from there. So in this way, you can actually, integrate using the AI agent from here. See, from Pydantic AI, you can import the agent, and it has also used the AI models, OpenAI model as well, to create and, insert all the information to the knowledge base. It has also given a system prompt like you're an expert at Pydantic AI, a Python agent framework that you can access all the documentation to. So this is the system prompt from here. And when you first look at the documentation, you can always start with the RAG. Then we will also check the list of available documentation pages and retrieve the content of the pages if it will help. Always let the user know when you didn't find the answer in the documentation or in the right URL, to be honest. And so you can integrate it using this function. So in this way, you can create your own AI agent tool, and then you can retrieve a list of all the available Pydantic AI documentation pages, and then it will return the list of unique URLs of all the documentation page from here. See, it has retrieved the full content of a specific documentation page by combining all the chunks now. So it's very simple and easy. So in this way, you can create your own chatbot agent as I have explained to you. Let's wrap this up by talking about why Crawl for AI is perfect for RAG. So with the help of Crawl for AI, you can actually scrape websites and turn them into high quality data sources for your AI. First of all, it will ensure the speed, that is, it scrapes data much more faster than any other tools. It's memory efficient. It's designed to handle large amounts of data without using too much memory, which means you can scrape entire websites without crashing your system. It's also flexible crawling, that is, you can crawl a few pages or thousands depending on your needs. So with the help of the combination of the speed and efficiency, it will make Crawl for AI a great tool for RAG and enable your AI to have access to most up-to-date knowledge in record time. So guys, that was a complete breakdown of how Crawl for AI can help you create powerful AI agents using RAG. So by gathering relevant data, web crawling, cleaning it up and feeding it to your AI model, you can make your AI an expert in any subject you choose.
Thanks for joining us in this journey into the real world of retrieval augmented generation. We hope you have a strong grasp on RAG works, how it differs from other augmentation techniques like CAG, and how tools like web crawlers enhance its performance in practical AI systems. Whether you're building applications, researching generative models, or just exploring the latest in AI innovation, you're now equipped with deep understanding of how to make AI systems more grounded, reliable, and useful. Keep experimenting and stay at the forefront in AI revolution. Keep learning from Simplilearn.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.